Well, hello. You must be here for a little nudge on problem 69 from chapter 32, and I'll see if I can get you started here. Well, here's a rather blurry picture taken from the textbook, but it's enough to see what I want to get you started with, and that is to recognize that because we have two different EMFs, battery-type devices in this, that it does not make it a good candidate for circuit reduction, but instead we'll have to use the two Kirchhoff's laws to create a system of equations. And so the key in this one is to figure out just how many independent equations you're going to need. So let me outline how many different currents you would be able to measure at different points in this circuit, because however many different currents you have, you need that many independent equations. So if you just go and trace lines between junction locations, you'll recognize the currents. So here's a current here running through what I'll call maybe the left side. And then we have a different current here running down there, and then we're at a junction again. We have a third current over through the right side. We have a fourth one down through that angled little branch. And finally, if you can see it there in purple, we've got a fifth value along the bottom, which is what they ask you about here. So that means you're going to have to come up with 5 independent equations. So the process here begins with naming each of those colored currents and deciding on a direction that you think they might be going. Now, it's not important that you know the actual direction of the current through each of those, just to be able to draw a little arrow to specify what you think it might be. And then if your answer comes out negative, you'll know you were backwards, which is perfectly fine. And then you need to come up with loops or junctions. Now, when you have 5 different currents, that's going to mean you need 3 loop equations and 2 junction equations. So you can pick a couple of junctions. For example, you could have a loop here on the left, and you just specify what direction you'd like to traverse that loop. Here's another loop here. We've got a middle loop here. But actually in this one, you could create a loop around the entire perimeter of the circuit like that. And any of those would be okay. You could even create a loop. This is going to be a little unusual, but you could start here and go around, go along the bottom and up like that. So any 3 independent loops. And then you need junctions. So you got a junction, let me pick a good color here. Got several junctions to pick from here in light blue. There's one at that corner. Here's one in the lower right. Here's one in the center. So any 2 of those 3, you just describe the currents going in and out. And those will be 2 of your 5 equations. And then my recommendation is if you don't know how to use the solver on your calculator, this would be the best time to learn how. Somebody can show you in real short order. It saves you a whole lot of algebra work or matrix work, which was my style of doing it back because I didn't have a solver. But regardless of how you get the thing solved, it's the key, the physics, is coming up with the 5 independent equations. So really, it's just, I guess it's a typical Kirchhoff's law problem. It just has 5 different solutions we're looking for rather than the maybe typical 3 that we've seen. But other than that, hopefully you'll recognize the process. So hopefully that gets you a nudge that you need. And if you have questions, you can always find me in the classroom.